Hello, my AB people. Mr. Lee Rosignol here, just checking in with you guys. I just want to show you a couple of things and then we'll go through some solutions for 7.2. You're on the welcome page here, and then if you go down the left side over here, we got two different pages really that have some work for this week. So make sure you check out both of those. This second page here, it's going to have some stuff for next week as well. But clicking on the first set here, we've got, let's see, a 7.1, a 7.2. You got the video over here. Remember, before you start the video, you should be, printing out these handouts over here. So sometimes it's just one handout. This one, I just put this solutions right here. So if I were to click on that, I can show you the solutions. But so you can look at those. That's just, a PDF of the solutions. I've already kind of set them up. So I'm going to take a look over here at, we're going to look at number 2, 6, 8, and 9. And 2 is a tricky one. So in fact, I'm going to do 2 last. Let's go to number 6. Number 6 first. Okay, it says for what value of k, if any, is y equals e to the 2x plus k e to the negative 3x a solution to the differential equation for y minus yada 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 yada. Okay, so the first thing we're going to have to do is realize to verify this right here, to verify this, you need to have that second derivative to plug in. So what you want to do is go take the second derivative. First, here's the first derivative, here's the second derivative. Don't forget, you got chain rule and you got that 2 there. So derivative e to the stuff, here's your e to the stuff times the derivative of the stuff. 2 comes down to the front. Same thing over here. K is a constant. Ignore it. Derivative of e to the negative 3x is itself repeater, but it's got a chain rule. Derivative of negative 3x, the negative 3 comes down to the front, so you got a negative 3k e to the negative 3x. Repeat that process. 2 comes down again, you get a 4 e to the 2x. Negative 3 comes down again, times a negative 3 gets you a positive 9, k e to the negative 3x. All right, so then from there, we are going to take that equation right there, and we're going to copy it right here. And all we're trying to do is now plug in fact, let me use some colors here. We're going to take this stuff. That's y double prime. We're going to stick that right here. Okay, and that's this stuff right there. All right, and then let's see the y. Let me use a different color for that one. So y, which is this stuff right here, is going to go right here, which goes right here. So you just substitute that stuff in and you do some distributive property and then you work your way through it. Being really careful here, you notice there was a 4e to the 2x and another 4e to the 2x. One was plus, one was minus. So those are going to cancel out. Then you got a 4k minus 9k. That gets you a negative 5k e to the negative 3x. They have to have the same power, remember. And then we can bring that 10 e to the negative 3x over to the left. All right, from there, we're trying to solve for k, right? Remember, it said to find what's the value of k. So what we're going to do is factor out that e to the negative 3x. We could have factored out a negative as well. We also could have factored out a 5 or a negative 5. But I'm comfortable leaving the negative 5k minus 10 in there. And then we're going to just set those two things equal to 0. The second equation is the one that yields the answer. And there you go. There's your answer for number 6. All right, moving on to number 8. Let's see here. Here's number 8. I like these. Whenever they've got a 1 only, 2 only, 3 only, you can typically cancel out some answers pretty quickly. One thing I noticed is that if I try the second one first, that's actually easier to take derivatives of because it's a repeater, right? I can do 1 first if I want, but I like 2 first because it's a little bit faster for me. But that's personal preference. I think it's easier for most. And after that, 3 would probably be easiest after that. And then, not that trig is hard, but you're gonna have to switch from sine to cosine and then cosine back to a negative sign, and there's chain rule, and you could lose some things in there. All right, so what we did is we took the first derivative, and then we took the second derivative. Remember, we got that 2, the chain rule comes down, so e to the stuff, there it is, times the derivative of the stuff, which is 2, times the 3, there's your 6 out front. All right, and then take the derivative of 6e to the 2x, get your second derivative, and then we are, again, like we did recently, we are plugging into a very specific differential equation. We need the second derivative, so this is going to go here, and then we have this will go here, And then let's see, we got one more color. That's going to go right here. So we're going to plug those in. So if you can see it down here, let me see if I can do this. Here we go. This right here, this 12e to the 2x, that's simply my second derivative. Then we got minus 6. That was a minus 6 right there. Says it right here. I'm going to go minus 6 times my y prime, and y prime was right here, so I just throw that in there, plus 8. 8 times y, 8 times y, and my y was over here, so I'm just going to throw that in there. And we just distribute and clean things up a little bit. All right, looking at my terms down here, we all have an e to the 2x. Okay, that's big for us. We all have an e to the 2x. So all you're doing really is adding these numbers. 12 plus 24 is 36, minus 36, you get a 0. And if 0 is equal to 0, well, that's looking pretty good for us. So what we just figured out is it's going to be 2. It could be 2 and 3. It can't be 3 only. It can't be 1 only because we know 2 works. So I won't even try 1. I'm going to move on to 3. And I did that down here. I'm not going to go through every single detail on that, but you'll notice I've got my first derivative. I got my second derivative. Let me talk about the first derivative, and I'll let you look through the rest of the work there. My first derivative, let's see here. I'm starting with c. Oops. I'm not sure what happened there. I'm not sure why it's disappearing. All right, we'll just look at it up here. We got c e to the 4x. You're going to go e to the 4x. You're going to keep that constant c out in front, and you're going to multiply by the derivative of that 4x, which is an extra 4. So you get a 4c e to the 4x. All right, so then from there, you're going to take the derivative of that, keeping in mind that, I'm not sure why that won't disappear, but anyhow, get your second derivative, that's 16c e to the 4x. And then we're going to go plug into that differential equation, right, that we had given in the original problem. Plug it all in. You're going to find out 3 also works because you get 0 equals 0. All right, so 2 and 3 both work on that one. All right, number 9 coming up next. All right, number 9, I believe, let's see, what are we looking for? We're looking for a k value this time. So we're going to solve for k. Oopsie. Let me shrink that down for a quick second. All right, so for this number 9, it's similar to what we did before. We're still looking for a value of k, kind of like in, I think it was number 6. So we're going to need to go find a first derivative, and in order to do that, we look at the original equation. But we don't really need the first derivative to be plugged in if you look at the differential equation here. Okay, the differential equation, it requires a y double prime, and it requires just y. There's no single prime. But we need to go get the first derivative so that we can go get the second derivative. All right, so do that, and now you're going to substitute into that equation right there, y minus y double prime over 4. So here's y right here, and here's the over 4. I put that out front, and here's my y double prime. That's just taking this stuff and throwing it in. All right, and then we just do some algebra and clean things up a little bit. We got some nice cancellations here. And then we end up with, let's see, k's on the left, no k's on the right, but we can get through it. We can bring that right term over to the left. They both have an e to the 4x, and we recognize that, so we're going to factor that out. I also factored out a negative sign. You don't have to, but you can. It just seemed like the right thing to do this time. And then I'm left with a positive 3k plus 5. Of course, we get no solutions on an e to the 4x because that's an exponential growth function. It does have a negative out front. If somebody was asking what does e to the 4x look like, that would be this, and negative e to the 4x would look like that. But either way, it is never, ever, ever going to be 0, right? There's the 0 line. It's never going to get there. All right, so we solve the other equation. We get k equals negative 5/3, and we're done with number 9. All right, I'm going to go back to number 2, and I'll do a quick discussion of number 2. Let's see, where'd we go? 2, by the way, if you watch the whole video through and through, which you should watch the whole video every time, not mine, I'm talking about the College Boards. They did mention toward the end in the last 5 minutes or so that number 2 was left for you guys, and it was a challenging one. They even said, hey, your BC students will probably do a better job on that or something like that. But anyhow, we can handle this. We have the techniques for it. The trick here, though, is there's lots of details. We're going to have to do a fair amount of work to get through it. You'll notice over here, if you plug in, if you plug in x equals 0, you should get y equals negative ln 4. That happened for all of A, B, C, and D, not E. So really, the only one we got to cross out using that technique was E, and that's a bummer. That means we have to investigate these 4 other ones. So there are 2 ways to go about that, or 2 techniques we're going to have to use, and we're going to bring them together. One of those techniques is you're just plugging in for y. You have this equation, dy dx equals e to the y plus x. Well, here's e to the y plus x. I took the y and I plugged it in. It says e to the y plus x. Here's my y, here's my plus x. The x and negative x cancel. I'm left with e to the negative ln 4. We have a rule that says you can bring that 4 down, but you cannot have the negative here. So if you were to keep working with that, you'll find the following. That's e to the ln of 4 to the negative 1, which turns out to be 4 to the negative 1, also known as 1/4. Now, the other side of this, the other process, you want to take a derivative. So there's 2 things, plug in for y and then take a derivative. So just go to the original equation, take the derivative. The derivative of negative x is negative 1. Derivative of a constant, gone. So now just look at these. They're not equal to each other. E to the negative ln 4 is never going to be negative 1. So A is out. Similar routine for B. I'm not going to go through every little detail here, but I'll let you kind of check through that work here. Here's the plugging in technique. Here's me taking a derivative. The derivative's easy. Derivative of x is 1. ln 4 goes away. I don't think all of that mess is going to turn into a 1. So B is out. C, let's see. C, plugging in, I'm taking all of this. I'm plugging it in for y plus x. Okay. There's a lot going on here. But what I'd like to do is get that negative off of there, put it up top, right? How do you get that fruit down from the tree? You hit it with a log and it comes down to the front. Or you can throw it back up into the tree, feed the baby monkey, right? So now I'm going to break this into 2 e to the x's because I can. I got that plus sign right there using an old exponent rule. And I've got a basic e to the x off to the right. And I've got e to the ln of stuff, and that stuff gets to drop down. All right, we're looking pretty good now. That stuff still had a negative 1 power on it, which can move it to the bottom. And then if you go back and take the derivative of the original, you're going to get negative 1 over the stuff times the derivative of the stuff. These negatives will cancel out. You're going to leave the negative e to the x on the bottom plus a 5. E to the x is on the top. Those are equal. All right, it's looking like it's going to be C. If you're pressed for time, I would just stop right there. If you try out letter D, you'll find out it's not going to work. You'll see that down here. All right, hopefully that was helpful for you guys. I know this is some challenging stuff. You're going to see some review at times. You'll see some review of old stuff mixed in with some new stuff. But keep pushing, keep asking questions. You can send me questions via Remind. You can email me, whatever you'd like to do. All right, signing off for now. We'll see you next time. Miss you guys. See you soon.